This is our planet, the Earth. It's a remarkable, ever-changing world, full of natural wonders. But there's more to Earth than this, much more. Because our planet is unique in the solar system, perhaps even in the universe. 4.5 billion years have made it a world of extraordinary landscapes and a home to life. My name is Ian Stewart, and I want to show you how our planet works. I'm going to explore volcanoes. They're terrifyingly destructive, but they're also the most fundamental force on the planet. Volcanoes are part of a global system that continually reshapes our world. They hold the key to the origins of life on Earth. They saved the planet from possibly the biggest crisis it's ever faced. And they've even formed a partnership with life that keeps our planet habitable. Ethiopia, Eastern Africa. This is the Afar region, bandit country, so I've hitched a lift with the Ethiopian military.
I'm off to one of the hottest and remotest places on the surface of our planet to see the most powerful force on Earth in action.
We've got plenty of equipment because ahead of us there's some serious climbing. We've touched down on a dry, brittle surface of recently cooled lava. I've come all this way to see one of the most remarkable volcanoes anywhere on the planet. It's called Erta Ali. The name means smoking mountain to the local Afar people. It's reckoned that the lava lake has been active for at least 90 years, making it one of the longest known eruptions. But no one's quite sure because it's only been properly studied for the last 40 years. I've been lucky to see a lot of volcanoes in my time, and I've never seen one that has a permanent lake of molten lava in its crater. But there's another reason why this volcano is very special. And to see that, I need to get down into the crater and see the lava up close.
Sit back, after. Release here. Okay. That's it, that's good.
It's close to a 100-foot drop to the terrace below. I've waited until sunset to take a closer look because the lava is at its most spectacular at night. This is as close as I can safely get.
Oh wow, really? That is magnificent. I mean it's taken us a hell of a journey to get here, but that makes it all worth it. I'm standing on the edge of an active volcano, right next to a big pool of molten lava.
What makes this lava lake more than just pure spectacle is that it's a window that allows us to look deep into the Earth. And it helps us understand the forces that shape our planet. Just take a look at the motion of the lava lake speeded up. It wells up on one side of the crater and forms a dark crust as it cools. Then this crust moves across the surface of the lake, driven by the churning action of the lava below. Finally, the crust sinks back down. This process of molten rock churning away below the surface affects the planet on a global scale. But the Earth's heat does far more than simply fuel volcanoes. It continually rebuilds the planet's surface. And it created the conditions for life on Earth to begin. To understand where our planet's immense inner heat comes from, you have to go back 4.5 billion years. This is the time of our planet's birth. You may not recognize it, but this is the Earth. Little more than a few pieces of rock colliding as they circle the sun. But these impacts produced immense amounts of heat, as did underground radioactive decay. Eventually, when the outer layers of the planet cooled, these powerful sources of heat were trapped in a huge hot core. The center of our planet is around as hot as the surface of the sun. This is the source of Earth's vast heat energy. And it's what fuels volcanoes to this day. Earth's hot core has been continuously releasing unimaginable amounts of heat since its formation. Even after 4.5 billion years, there's still plenty left. Volcanoes are the most obvious examples of the Earth's inner heat in action. But this inner heat also continually reshapes the surface of the whole planet. It creates a restless, constantly changing landscape. Iceland is a great place to see exactly how the planet's inner heat is able to transform the surface of the Earth. Magma usually lies many miles beneath the surface, but here in Iceland it's much closer. And that has a dramatic effect. Sulphurous fumes and bubbling hot pools with 100-degree plus temperatures hint at the power that is just beneath the surface. There are naturally heated pools everywhere on the island, which makes going for a dip something of a national pastime. But the people here might not be quite so relaxed if they knew exactly how the water gets heated. Just 12 miles beneath Iceland is a vast column of superheated rock called a plume. It's over 100 miles wide and at least 370 miles deep. Created more than 50 million years ago, the plume is sustained by heat continually rising up from Earth's